Learners, in first part of this reaction, we had discussed about the Claisen rearrangement reactions and all its variants. Learners, we will be continue this sigmatropic rearrangement reactions in this part of the lecture, and we have to learn different type of sigmatropic reaction, that is Cope rearrangement reactions, Cope rearrangement reaction, Oxy-Cope rearrangement reactions, Manich reactions, and other nth type of sigmatropic reaction, that is 2,3 Wittig reactions, 2,3 Stevens rearrangement reactions, and Somlet-Hauser rearrangement reactions, and also Mason-Henner rearrangement reactions. So learners, first we will learn what is Cope rearrangement reactions. Learners, this is also 3,3 sigmatropic rearrangement reactions follow Woodward-Hoffmann rule. So what is the Cope rearrangement reactions? Learners, here in Cope rearrangement reactions, 1,5-diene thermally induced isomerize into a new product. So on heating 1,5-diene, we get isomers of 1,5-diene where 3,3 shifting of groups takes place, and this is called Cope rearrangement, right? So again here we get isomeric constitutional isomers of 1,5-diene where 3,3 groups, allyl groups shifting takes place. Now we will say here this is 1,5-diene, right? So you are looking on the screen 1,5-diene. When this 1,5-diene thermally induced migration of 3,3 takes place here, again formation of a new bonds takes place at 3,3 position, and breaking of sigma bonds takes place at the bond between allylic carbon atom. So this is a symmetrical 1,5-diene, and such type of rearrangement reaction is also called degenerate rearrangement reactions, and here starting material and the products are same, right? Because both are isomers of each form. This is the constitutional isomers where the number of carbon, number of functional group is same, but the position of functional group is different. That's why this is a isomeric form of its reactant. So always remember learners, here we get a isomeric form of reactant, and this type of reaction is called degenerate Cope rearrangement, because this is a symmetrical 1,5-diene. Now we will see how the mechanism, how the reaction takes place. So you are looking on your screen transition state, which is a chair form. So this transition state is energetically and structurally equal to the diradical. So that transition state, we get a two type of transition state here. One is boat form and one is the chair form. But boat form transition state is very stable state, and we get a stable product. So this is also irreversible reaction, because the product which we will get in Cope reaction in 1,5-diene from the 1,5-diene is very stable. It is a degenerate Cope rearrangement, which is 3,3 sigmatropic shift, and in this 3,3 sigmatropic shift we get a two states, as you have seen in the previous slides. One is the lower energy chain state, another is a higher energy boat states. So this reaction is also called self-replicating Cope rearrangement reactions, right? Again here mode of interaction is superficial, where both the HOMO and LUMO migrate on the same phase. Groups allylic carbon which are having the p orbital migrate on the same phase. So 2 pi bonds are breaking the first form, 2 pi bonds are breaking, and 2 new pi bonds are formed. Similarly, in the another form, 1 sigma bond is breaking and 1 sigma bond are formed during the reactions. This is another example, Cope rearrangement reactions. Learner, this is also 1,5-diene, right? But here you are looking here, one CH3 group attached to the carbon atom. Again here, HOMO which is unsymmetrical, having p orbitals. Superficial mode of interaction takes place. In transition state, we get a diradical type structure, and finally we get other product which is the isomeric form of its main substrate. So always remember, Cope rearrangement reactions, we get isomeric product. This is another example. You can see another form, the 1,5-diene substituted diene, where the carbon having CH3 group, we get a transition state which is a boat like transition state, and finally we get a isomeric product of its reacting material, reacting compounds. Now what happen here? Shifting of groups involves in interaction between two allyl radicals. Cope rearrangement follow allowed concerted route through Huckel's aromatic transition states. This is also highly stereospecific reactions. As I told you in the previous lecture, stereospecific reactions are those reactions where one of the stereoisomers dominates over other isomeric forms. So Cope rearrangement required heat to cope with energy barriers. Learners, at room temperature, Cope rearrangement reactions relieves ring state and interconvert faster, right? So this is a cyclopropane, and here ring strain is very less, that is minus 27 kilocalorie per mole. Here we get isomerized product at 5 to 20 degree Celsius temperature, and this reaction is a very faster reactions. The reaction takes fast. So here you are looking here, the bond between 3 and 4 position, the cyclopropane, the cap which is represented at the bond between 3 and 4 is broken, and the new bond between 1 and 6 position is formed. So this is another isomeric form of that cyclopropane. You are also looking here, it is a rapid, we call rapid degenerate Cope rearrangement reactions, where we get identical product to the starting reactant. So you are looking here, Cope reaction which is thousands times faster per seconds. It requires heats to cope the energy barriers. So this is type of reaction is called rapid degenerate Cope rearrangement reactions. Famous example, this is bulvalene Cope. It is a bulvalene molecules, and it is very famous Cope reactions. What is the bulvalene? Learners, there is a cyclopropane base, and on that cyclopropane base you are looking here 3 allylic groups, right? So that is 3 double bond you are looking here, which are having 1 C which is attached to the 1 CH2 unit. So what happened here in bulvalene? Learners, on heating it converts into fluxinol molecules. What are the it breaks rapidly, and in fluxinol molecules all the carbon and hydrogen atom appears equivalents. So fluxinol are no non-rigid molecules can change rapidly into another form. All atoms can interchange between, and there is a symmetry in the bond, and all are having equivalent positions. So bulveleno is a homotropylidine having two methyl groups are bridged by double bond, and also same just a flexinol structures. Now modification of Cope rearrangement reactions. So these are the variants of, as we have learned, variants of Claisen rearrangement reactions. We will see here variants of Cope rearrangement reactions too, that is called modifications of Cope rearrangement reactions. First is Oxy-Cope rearrangement reactions. What is Oxy-Cope rearrangement reaction? This is also 3,3 Sigmatropic rearrangement reactions. Here OH group is attached to 1,5-diene. So learner, in Cope reactions that is having 1,5-diene, but here on that 1,5-diene, one hydroxyl group is attached. The rearrangement proceeds faster. So it's very important. Oxy-Cope rearrangement is more than thousands times faster than the Cope rearrangement reaction. So the oxygen gets stabilized. We will get here anionic oxygen which is having a negative charge that stabilize, and we get a very stable product. So this is an example of Oxy-Cope rearrangement reactions. So here 1,5-diene, on that diene you are looking here allylic carbon, on that allylic carbon OH group is attached. So due to presence of that OH group, this is rate of reaction is very fast, and here we get a very stable ketone. So this is reaction is called Oxy-Cope reactions. Now we will see here mechanism of Oxy-Cope reactions. How the rearrangement takes place in Oxy-Cope reaction takes place in presence of base. Here stabilization of negatively charged oxygen, and that negatively charged oxygen is get converted into unsaturated carbonyl compounds. So this is also 4n plus pi system. Follow Woodward-Hoffmann rule. Thermally induced reactions, mode of interaction is suprafacials. Learners, this is another example. This is, we are looking here a cyclohexene ring which is attached to 1,5-diene system, and one of the 1,5-diene having what? Alcohol or hydroxyl group. So the same 3,3 migration takes place and we get ketone over here. Another example of Oxy-Cope rearrangement reactions, there is also 1,5-diene. So always remember, Oxy-Cope, the allylic carbon having hydroxyl group, but here that allylic carbon having hydroxyl group, also one substituent which is R or CS3 group. Here migration of 3,3 groups takes place and we get a very stable products. This is another variant of Cope rearrangement or Cope rearrangement. Sigmatropic reaction is Aza-Cope. So as we have learned in Claisen rearrangement reactions, so this is also same type, Aza-Cope reactions. What is Aza-Cope reactions? It is a heteroatom version of Cope rearrangement reactions. Again here rearrangement proceeds, 3,3 migration, suprafacial mode of interaction, heteroatom lowers the activation energy barrier. Now you will find out this is a 1,5-diene where that diene having heteroatom, right? So N is a heteroatom which is present in 1,5-diene. Migration, 3,3 migration, suprafacially 3,3 migration takes place and we get isomerized product, that is a NH. azo. We are having azo, carbon and nitrogen having double bond. So this is here azo group. Now very important reaction is a Mannich reactions. Now what is Mannich reactions? Learners, this is also a variant of Oxy-Cope reaction. Here thermally induced reactions, the reaction required some temperature, 3-3 migration of shifting takes place, the HOMO and LUMO of the reactants overlap superficially on the same phase, we get a very stable product, that is amino-carbonyl compound. So this is called Mannich reactions. So another important reactions, which is a NM type of reactions, we are looking here, where the migration of allylic carbon takes place and we get a new bond. So always remember, learners, NM type of reactions, the migration of a groups that we called migration origin to takes place to the migration terminus. So here NM type of reaction, that is 2-3 reactions, it is Wittig reactions. So Wittig reaction is also 2-3 sigmatropic rearrangement reactions. In Wittig reaction, allylic ether convert into alcohol. So it's very important rearrangement reaction of which follow again superficial mode of interactions and we get a allylic alcohols. So all these reactions are very important in organic synthesis. Again, variant or modification of Wittig reaction is Wittig rearrangement reactions. This is also 2-3 migration reactions where allylic tertiary amine change into homoallylic secondary amine and useful in the formation of substituted cyclic secondary amines. This is the example we are looking here, we get a secondary amine. Another very important rearrangement reaction is sigmatropic rearrangement reaction is 2-3 Stevens reactions where rearrangement of quaternary ammonium salts or sulfonium salts takes place and the reaction takes place in presence of base and we get a very stable product. And the last rearrangement reaction, which is the sigmatropic, is Somlet-Hauser reactions. Here new alkyl groups in aromatic group chain or aromatic ring is shifted at the ortho positions. So here you can see here at 3 position, which is the ortho position, aromatization takes place or new alkyl group is shifted. Meson here rearrangement reaction, it is also NM type of reactions which is called 2-3 sigmatropic rearrangement reactions, allylic tertiary amines and oxides to give allyl hydroxyl amines and we get a very stable product. Last very important reaction, that is a benzidine rearrangement 5-5 sigmatropic reaction where 10 electrons involves and it is a rare migration. It's very important in organic synthesis. So here hydrazone arenes change into diamino biaryls. So this is the reaction, benzidine reactions. We are looking here 5-5 migration of shifts. So here we get biaryls, 2 aryl ring having NH2 group. So learners, in this lecture we have learned a very important reactions, Cope rearrangement reaction at modifications of Cope rearrangement reaction, that is Oxy-Cope reactions and Oxy-Cope reactions and some other important sigmatropic rearrangement reaction which are very important in organic chemistry. Thank you.